Good day everyone, my name is Hirashini Anna Perempuan Ganesan, currently doing Bachelor of Science in Mechanical Engineering under the supervision of Associate Professor Dr. Safa Najah Saud Al-Humairi. The title of my project is Influence of X-Carbon Nanotube Why Thin Additions on the Tribiological Behavior of Porous Titanium-Based Shape Memory Alloys. It is well known that 90% of aged population are suffering from all those kind of degenerative diseases such as osteoporosis and arthritis. Until now, the best solution for curing all these kind of diseases is by surgical restoration or replacing them by artificial biomaterial. However, in some application, it may lead to premature failure. Loosening is one of the most common failure in which debris from porous material causes extensive osteology and catastrophic failure. Therefore, the objective of my project is to develop a sustainable porous titanium-based shape memory alloys through the binary addition such as carbon nanotube and tin with a different weight percentage. The second objective is to systematically investigate the effect on the binary additions on the microstructure and the tribiological behavior of porous titanium-based shape memory alloys. As for the significance of my project, this project aims to develop a sustainable porous titanium-based shape memory alloys which is safe, effective, and high quality for both generation, which is elder and younger, without any long-term health issues. It also correlates to my SDG, which is SDG 3, good health and well-being, and SDG 9, industry, innovation and infrastructure. The limitation of my project is porous or modified titanium-based shape memory alloys are considered to be expensive. That is one of the disadvantage that I would say that I got into my project, since I will be using a large amount of it. Next, I will be explaining the chapter 2 of my projects, which will be literature review. Shape memory alloys, or we can say SMA, is most commonly used behavior in variety of applications. It describes the process in which an alloy is deformed and keeps its shape in its cold condition. When the strain is too great to be released elastically, a large density of defects form in both methanside and parent phases, immobilizing the interface. When SMA with self-accommodated methanside is subjected to external stress, the version with the strain direction most favorable to the applied stress will eat up the other variants. There are two types of shape memory alloys. The first one is one-way memory effect and the second one is two-way memory effect. Past investigations demonstrate that superelasticity of titanium nickel is impressively influenced by testing condition during wear. In a friction test, it is obvious that the surface roughness of the alloy layer is higher. It also has been discovered that titanium nickel alloy has a better wear obstruction. Not only that, it is broadly known for shape memory and superelastic impact, which happen because of reversible metastatic change. Recent research shows that there have been numerous research investigations about different porous coating and fully porous matrices. Porous titanium-based alloys exhibit a good combination of mechanical strength and low elastic modulus. There are four main variables to be controlled in my project. The first is additions on the binary elements. To develop a more sustainable porous titanium nickel shape memory alloys, carbon nanotube and tin will be added. Titanium nickel shape memory alloys is considered to be a rough material. Carbon nanotube will be added to reduce the roughness of the material because it is known as a high lubricant material. Tin is also been added to increase the toughness and durability of the material. The second variable is applied load, then applied speed, and lastly the concentration of binary addition. Shape memory alloys are widely used in many fields. For instance, orthodontic, orthopedic, vascular, dental, neurosurgical, and many other applications. Next, I will be explaining the research and methodology of my project. Pure titanium and nickel powder, which is 99.5% and 99.7% purity, being used respectively for this experiment. Binary elements, which are pure carbon nanotube, and tin being used with a purification of 96% and 99.9% respectively. All the materials are purely produced from United Kingdom using average particle size. Porous materials, which is titanium and nickel, was prepared with a different weight percentage of binary additions, carbon nanotube and tin, which for carbon nanotube I use 0.5, 0.75 and 1 weight percentage. Therefore for tin 0.5, 1 and 1.5 weight percentage according to data of experiment. Then mixture of 10 gram was prepared by using the tumbler ball mill. Each of the mixture was blended for 30 minutes using ceramic balls to break down the powder. All the samples were compacted by preparing 4 samples each under the load of 5 tons for a minute. Once all the samples are done with compacting process, then it goes to sintering process using tube furnace to produce green sample for about 45 minutes under the temperature of 850 degrees Celsius. The weight in the air and in the water have been recorded. According to Archimedes' law, in order to identify the relative density of all the samples, we have to measure the weight in the air and weight in the water. Then all the samples go for wear testing process. The variable that have been used are load and speed. For the load, I use 0.5 kg and 1 kg, whereas for the speed, I use 10 Hz and 20 Hz. All the samples been classified accordingly for the variables based on the design of experiment that I've planned earlier. Next, I will be explaining about the result and discussion that I've obtained for this experiment. The results that are shown in the slides are the partial result that I've obtained during my experiment, which is done based on the design of experiment that I've planned. The graphs are plotted to find out the relative density, porosity, wear loss and the depth of the samples. Based on the result that I've obtained, it shows a linear relationship in each of the parameters. By this, it can give us a better understanding on what is actually going on those samples. The samples are then studied under microscope to get a microstructure, and they are transformed into 3D to get a better image on the worn surfaces. In addition, 3D bone stimulation was also done to determine the stress distribution on the bone when the material is placed. The load that has been applied is 500 Newton, and it can be seen in the result that it is safe to be used. Last but not least, in conclusion, the objective of the projects have been achieved. As the first objective, a sustainable porous titanium nickel shaped memory alloy through the additions of binary elements such as carbon nanotube and tin with different weight percentage has been developed. The weight percentage for carbon nanotube is 0.5, 0.75 and 1 weight percentage, therefore for tin 0.5, 1 and 1.5 weight percentage. There were different variables being used to obtain these results, which are speed and the load. The speed that have been used are 10 Hz and 20 Hz, whereas the load is 0.5 and 1 kg. There were total of 40 samples being experimented. The experiment was done based on the design of experiment for all the variables. As for the second objective, the effect on the binary additions on the microstructure and tribiological behavior of titanium nickel shaped memory alloys have been systematically investigated by obtaining the results on the wear behavior. Through the 3D microscope, we can see and measure the depth of the wear that have been occurred after ball on disc have been penetrated during the wear test based on the variables that have been set on the design of experiment. This project aims to develop a sustainable porous titanium shaped memory alloy that is safe, effective and high quality for use by both older and younger generation without having a long-term effect. In addition, carbon nanotube and tin act as a novel additions to the world of biomedical. There are some future recommendations that I would like to recommend for this project. In this research, there were only 4 parameters were varied at a very limited point. For a better understanding on the tribiological behavior of the alloys, the parameters can be explored at a more different variant and increase on the number of the samples, so the result would be more accurate. These can be more understandable to carry out this research in the future. With this perspective, I would like to end my presentation. Thank you so much.